Okay, for problem number 1, we're trying to find the thermal conductivity for this apparatus. We know the inner and outer temperatures, and we know the electric power that's supplied to it. We can assume that this is isentropic, constant K. The system is symmetric based on the dimensions of the box, because they're the same. The top and bottom are perfect insulators, and this is one-dimensional conduction. And you can plug all those things into the equation right here, and we know that time varies linearly with x, and so you can do all the adjustments. For number 2, we are trying to find the heat transfer term for convection, and we're given the heat transfer coefficient, and so we can just plug all those things into the equation right here. And then if you do a little bit of manipulating with units, you can get the cost for the year. For number 3, we're trying to find the surface temperature when the heat absorbed is equal to the rate of it being emitted. And so we're given the epsilon value and the alpha value. I think this is permittivity, and this, I can't remember. And we're given the heat rate from the sun, which is the emitted value. And there's an equation for that right here from our notes. And you can just plug and chug. Those ones we don't need to worry about. And then for this last one, we have a value or an equation right here. And you can just use table 14-1 to input all of the values, and it's just plug and chug, and that's what you get. And I guess I'm still kind of confused about knowing like the absorption and what's being emitted. Like, how do you know what's the surface? I don't know. And for this last question, I don't really understand what this equation represents or why we need to use it, so that would be helpful to know.